So find the particular solution of differential equation that satisfies initial equation. So they gave you this, they gave you that, they gave you this. So if I want to find the particular solution, means I need to use this information to figure out what C is, okay? So first thing I'm gonna do, so I'm gonna take a derivative of this function. All right, it gives me f prime, right? When you take antiderivative of double prime, gives me a prime, right? So I'm gonna put it in. So 6x squared dx, well, I can rewrite it as 6x to negative 2 dx. So I just find out f prime of x is equal to 6 times x to the negative 1 and divided by negative 1 and plus c, right? Or I can rewrite it as negative 6 over x plus c. All right, now look at this. They gave me information to replace c because they told you f prime of 1 equal to 9. So I can say f prime of 1 has to be equal to 9. So negative 6 over 1 plus c. So that gives me 9 is equal to negative 6 plus c. So c has to be equal to what, 15? So now I just found it. So f prime of x is equal to negative 6 over x plus 15. Now I want to find f. F of x is the same as antiderivative of f prime of x dx, which means negative 6 over x plus 15 dx, which is the same as, so this is just antiderivative of a natural log. This is just a natural log. So I have negative 6 natural log of x plus 15x plus c. That's my f of x. Now, this is the time you are going to use this part now. It says f of 1 is equal to 2. So f of 1 is equal to 2. So negative 6 natural log of 2 plus 15 times 2 plus c. So when you plug it in all this number, then c has to equal to which number? According to that, it's equal to negative 13. So when you plug in natural log of a 2, what is that equal to? That's some number that you get, right? So you need to figure this one out. Natural log of 1 equal to 2. So natural log equal to 2. So you plug it in all this. 30 plus, I don't know what this number equal to. Put it in your calculator what that equal to. So then you get 2 equal to negative 6 natural log over 2 plus 30 plus c. So c has to be equal to, put everything to other side, 2 minus, let me use different color. C is equal to 2 minus 30 plus 6 natural log of 2. So that gives you negative, what? 28 plus 6 natural log of 2. So natural log of 2, what's the natural log of 2 equal to? Let me see what's that equal to. I'm going to look at that. Let me plug in my calculator. Change that into for this. I can use Julia. It's 0.69. So you have C is equal to 2 minus negative 26. Negative 26 plus 6 times 0.69. So negative 23.84. All right, so your answer is, so your solution is f of x is equal to 6 natural log of x plus 15x, and then this is your C, negative 23.84. So this is incorrect, class. Okay, and so maybe that's why you got it wrong, Shalia, Bernice?
Yes, ma'am.
Correct. So no, the C should be, this C, when you figure out that C is not equal to negative 13, so this is incorrect. That should be negative 23.84. Is that why you got it wrong?
I think so, because I tried to do it like this and my answer was not right.
All right, so if you do get it wrong, because because of problems like this, if I give you exam, I'm gonna look at your work. So I know even though WebAssign says you're wrong, if you think it's right, just send me a direct message through the WebAssign and say, Dr. Harris, can you check on this? And I will check manually for you. Like particularly the problem number 18, the answer to WebAssign is incorrect. The reason it's incorrect because they're using what? It says f of 1. You didn't say f of 0, but they've been plugging in as what? Zeros. That's why it's incorrect. They made a mistake on this one. It's a natural log of 2, not natural log of 0. So they made a mistake on that part. All right, so this is where they made a mistake here. All right. All right, any other problems you need to go over? So we can actually continue our lesson today because today's lesson is a continuation of what we're doing at 5.2, actually 5.2 and 5.4. Because today we've been looking at the natural log of what? We've been looking at the natural log of E, but E is equal to 2.7, something, 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 it's an irrational number. But now we're gonna say, okay, let's not just concentrate on E, but let's look at different number. Like how about natural log to the 2, or natural log to the 4, or natural log to 7, just different number. So we're gonna call that as just A. A is just a sum number. So define exponential function that have bases other than E, okay, other than 2.717, whatever, okay. Differentiate, integrate exponential function that have base other than E, and use exponential function to model compound interest exponential growth. All right, so let's look at this one. The definition of A to the X, or for example, like 2 to the X. All right, so I'm gonna call it let A to be 2. That means the definition is the same as E to the natural log of 2 to the X. That's what that means. All right, so I can think of this problem. If I give you, say, y equal to e to the x, what's y prime? E to the x, right? Because e to the x is e to the x. But now, if I give you, say f of x equal to e to the 2x, what's f prime of x? Then you're going to say e to the 2x times 2, because derivative of this is a 2, right? So it's the same way. So if I ask you to take a derivative of this, that really means I'm taking a derivative of that. If I call it that to be that, my y prime is taking a derivative of this, which is e to the natural log of 2 times x. And then you're going to say, what is the derivative of this? You're going to say the log of e. So my answer is, the y prime is equal to e to the natural log of e to the x times natural log of e. But natural log and e cancel out to be what? They're inverse to each other. So actually my answer is just equal to what? E to the x times natural log of 2. All right, so just because you have a different base does not mean anything changed. You do exactly the same way taking a derivative. So one more thing. this is nothing to do with calculus. This is just a review of college algebra in a way. So anything to the base, anything to the 0 power is a 1. If you have the same power, what do? You can subtract. You have the same base with the division, then you can make the power to be subtraction problem. If you have a multiplication of the same base, you can make it to be what? Plus of their power. If you have parentheses of that raised to that power, that means just multiplication. For example, 2 to the 3 to the 4 means 2 to the what? 12. If I give you 2 to the 2, 2 to the 4 means what? 2 to the 2 plus 4, which is 2 to the 6. But this case means 2 to the 4 minus 2 to the 7 means 2 to the 4 minus 7, which is 2 to the negative 3, or same as 1 over 2 to the third. So this is just the same thing you've been doing at college algebra, just to review that, because we're going to use that properties. And this is a model problem. You will probably see that in your chemistry class. They're asking you like half-life of carbon-14 is about 5,715 years. The half-life of carbon, okay, is a 15 years, 5,715 years. A sample contains 1 gram of a carbon-14. How much will be presented in 10,000 years later? So it's a half-life, so means half, right? The base is half. So you're gonna starting with let T to be 0 present the present time, let Y present the amount of ink gram in carbon in the sample, using the base to be half because it says half, okay? So that means I have Y equal to 1/2 the T to the 5715 because it told you half-life is 5,715 years. All right, so now, if when T is 5,715 years, it's exactly same years and you get half grams left. But I want what, 10,000 years. So you're gonna replace T to be 10,000. So 10,000 divided by 5,715 and raise their power to half. So 1/2 of, so 10,000 divided by 5,715 equal to 1.75. So that is equal to
Yes, Mom.
20 grams. 10,000 years later, the half-life of 1 gram, okay, 1 gram of a carbon-14 will be 0.3 grams. So 10,000 years later, you still have a 0.3 grams left, the carbon-14, starting with 1 gram. So this is another example of using a base other than E. You use this time the base to be half-life, which is a 0.5. So they're giving you an example, where do you use calculus? So you just figured out, yes, I can do my chemistry problem about the half-life problem by changing my base from E to 0.15, 0.5.
Yeah, come get in bed, watch TV.
Fabian, you need to mute. All right. Anybody have any questions so far? All right. So next thing, this is another thing that you probably remember, but I'm gonna just go over one more time. If you have a log base A, X, remember your calculator has a log, which is base 10, but we can have any base. It doesn't have to be base 10, it doesn't have to be base E, it can be base 2, base 5, base 7, any number. This A can be any positive numbers, okay? So if you have that, then if you want to change that into more conventional way, which means we use natural log and we use log base 10, that case you can rewrite this problem as natural log of X over natural log of A. So which means the base A goes to denominator, your log is in the numerator. So if I give you log base 2 to 7, then you can rewrite it as log, natural log 2 over natural log 7. Okay, you see that? That goes to numerator, that goes to denominator. The base goes to denominator. So you're dividing by your base. So you can standardize it. All right, so same thing again, just like a natural log. If you have a multiplication, you can make it into plus. If you have a division, you can make it into, if you have a power, you can put that in the front. If you have a division problem, you can make it to be a negative. And then log of 1, okay, just like a natural log of 1 is equal to 1. 0, excuse me, natural log equal to 0, and natural log of e to be equal to 1. So same thing, log base of 1 is equal to 0, because your graph looks like this. That goes to 1, 0. That's what natural log looks like. All right, so again, we know about this, just like a 5.4. So if you have a y equal to a to the x means x is equal to log base a y. All right, and then you can say a and log a, they're inverse to each other. Okay, they can cancel out to be 1. Okay, so if you have this problem, all right, if you have this problem, I'm going to rewrite this in terms of a 3. So 81 is the same as 9 times 9, which is the same as 3 squared times 3 squared. Or I can rewrite it as 3 to the negative 4. So you just figured out, you just said, okay, 3 to the x is the same as 3 to the negative 4. That means x has to be negative 4. All right, so you can look at your problem like that. Next problem, over here, it's a base 2. So I can rewrite as 2 and 2 over there, and 2 they cancel out, so you get x equal to 2 to the negative 4, which is the same as what? 1 over 2 to the 4, which is the same as 1 over 16. Okay, so you're just applying. This is just the algebra problem right now. So they want you to make sure that you remember your algebra, the law properties that you learn in algebra class or pre-calculus class. So I'm not doing calculus yet. I'm just utilizing what you already know. All right, so now it's differentiation and integrations. So derivative of a to the x, okay, a to the x is natural log of a times a to the x. Remember, a to the x is the same as e to the natural log of a times x. So this came from right there. The derivative of this part is what? Natural log of a. That's why you have natural log of a in the front times a to the x. Okay, remember this. All right, same thing here. So you have that, you will do exactly the same way. If you have a log, we're gonna do same way. So you're gonna do 1 over x, and then times the derivative of that, which is natural log of a. Remember, you can rewrite, note this. Log over ax is the same as what? 1 over natural log of a times what? Natural log of x. So when you take a derivative over that, you get a what? 1 over natural log of a, that's your just coefficient, and then 1 of x. That's how you get this. All right, so nothing new. You still, so just because the base is not e does not mean you cannot take derivative. You can take derivative just like e, but now you have a coefficient because natural log of e is equal to 1, but natural log of a is not equal to 1, okay? Unless a is equal to e. So that is why you have to write it down as your coefficients. So find the derivative of each function. So you're gonna do, this is y prime is equal to natural log of e, natural log of 2 times what? E to the x. So if I give you this, prime would be the same thing again. Then you're gonna say, okay, that would be natural log. I'm gonna put natural log of 2 first. I mean, because that's my coefficient. And then I'm gonna do exactly the same thing, e to the 3x. And then I will do what? Take a derivative over this, which is what? 3. So I can rewrite it as 3 natural log over 2 to the 3x. All right, in this case, I can rewrite this problem as natural log of 10 times natural log of a cosine x. All right, so now take a derivative of that. So y prime is 1 over natural log, it's just a number, so I'm not doing anything. Derivative of this is 1 over cosine x and times derivative of derivative of a cosine. What is a derivative of a cosine? Negative sine x. So we finished. So y prime is equal to 1 over natural log of 10 and negative sine x and cosine x, which is same as what? Tangent x. So my y prime is equal to negative tangent x over natural log of 10. All right, the next one is you need to make sure you need to make it into 2 parts. Log base 3 of the square root of x minus log base 3 x plus 5. All right, and then you're going to take antiderivative of that. So we can do that in a different page if you want to. So you get all this. So you have all this that I just did. For this problem, we need to look at the, make it into 2 parts. Over here. So I'm going to rewrite this problem. So this is same as x to the 1/2. So that is y log base 3 of x to the 1/2 is the same as 1/2 log 3x. So that's where you get that. All right, and next part is just like that, same. Right now, you're going to take a derivative of that. So you're going to rewrite this. Log base 3. I'm going to do this part right now. Okay. So log base 3 of x is the same as natural log of x times natural log over 3. Or I can just say 1 over natural log of 3 times natural log of x. So derivative of that is the same as 1 over natural log of 3 times 1 over x. All right, so that is why you have this right there. Next one, you have this. Let me use different color. So log 3 of x plus 5 is the same as log natural log 1 over natural log 3 times natural log x plus 5. All right, so I'll take a derivative of that. It's same as I'm taking a derivative of this, right? So we have a 1 over natural log of 3. It doesn't change anything. And derivative of this is 1 over x plus 5. And derivative of x plus 5 is just 1. So you have this, as you can see. So you combine them, then you get this. So it's a little more complicated, but you just need to do 1 part at a time. When you have many terms, you take your derivative or antiderivative 1 term at a time. Just like what I just did. I did this part. First one, I did this. And I did this one. So I did 2 parts because I have 2 terms, 1 term and 2 terms. So integration is opposite of that. Remember, we multiply. See, we multiply natural log when you take derivative. So when you take antiderivative, what would you do? Of course, you divide it by that. So derivative, you multiply by natural log of A. When you take antiderivative, what do? You divide it by natural log of A. So you have this, then you want to tell yourself, okay, you can think of yourself, if I give you y to be 2 to the x, and then y prime is natural log of 2 times 2 to the x, right? Or dx, I can say, okay. If I want to take not dx, actually this. Then you're going to tell yourself, okay, if I want to go back to this, okay, I need what? Natural log of 2. But I don't have that natural log of 2 here. So you're gonna do, okay, I will multiply by natural log of 2, and then I will divide it by natural log of 2. So that is why you have natural log of 2 times 2 to the x plus c. Does it make sense to you? Does it make sense that why we have this? Just like this, you're matching it, and you don't have that, then you apply them coefficient, and then you divide it by that coefficient, because natural log of 2 divided by natural log of 2 is 1. I'm not changing my problem. All right, power rules. So we can use the power rule just like that. So you have e to the e is just a number. So taking a derivative of a number, say 3, is 0. So e to the e is 2.7 to 2.7, it's a number. So when you take a derivative of a constant, it's a 0, of course. Derivative of e to the x is e to the x. Derivative of x to the e, okay, it's x to the e. So which means I'm taking say y is equal to x to the e, then y prime is what? E times x to the e minus 1. It's a simple power rule, okay? E is not a variable. E is a number, 2.717, it's irrational number. So if they gave you, they say find the x, then you're gonna do, if you have this, y equal to that, all right, then I'm looking for x, what x is equal to. The first thing you need to do, you need to bring down this x. I need to bring down front. So only way you can bring it down is applying the natural log. So you apply the natural log into here and natural log over there. In that case, you can bring this x to front, right there. Now take a derivative of a y, all right? That means it's the same as y, and derivative, that is what? Y prime. So that is why you have here. And in this case, you're gonna take the product rule. So f is x, f prime is 1, g is equal to natural log of x, and g prime is equal to 1 of x. So that's why you have, remember, f times g prime plus g times f prime. So f, g prime, g times f prime. So when you apply that, you get this. Now I can find my y prime, which is equal to, when you do that, you get this. Okay, now I'm gonna multiply by y prime, the y in each side. So y prime is equal to this. Now I'm gonna replace my y prime. I'm gonna replace my y. What's my y? Y is equal to this. So I'm plugging back in my y, which is this. All right, so now I got answer. That's my answer for y prime. All right, so now they're asking, let's do some application problem. You probably remember seeing this one for continuous compounding. Remember when you take your college algebra class or probability statistics class, they're gonna ask you about what is a compound interest. So compound interest is the one you're using in a way in the calculus, okay? Because it's a continuous interest. So amount of P dollars is deposited in account at an annual interest rate R. And what is the balance in the account at the end of 1 year? The answer depends on the number of times and interest is compounded according to the formula. So this is what do you call it? Discrete compound. So which means you're not compounding continuously. You do so often, like once a year, you get interest compound. Sometimes you twice a year, you get interest compound, or 3 times or 4 times. All depends. Okay? Depends on your bank. But right now, I think every bank usually do like a once a year for their compounding. So this is a formula for interest, how you find your interest for how often you compound. Okay, so R is its interest rate, and N is how many times does it compound per year. All right, everything else is known. Okay, P is a principal amount, the starting amount, principal amount. All right, so you have this. So for instance, the result for the deposit of a $1,000 at 8% interest compound N times a year is shown in the table. So if it's N is only compounding 1 times a year, you get $1,080. So a year later, you get $80 interest. If you compound twice a year, look at this, you get $81.60. If you compound 4 times a year, you get $82.43. If you do 12 times a year, which means every month your interest compound, you get $83. Look at this. If your bank compound every day, and you get what? $83.28. So my question, do you think your bank will compound every day or once a year, and why? Are you listening? That's right, the avian. It's once. Why? Because your bank want to give you
every day, would they lose more money?
That's right. If they compound more often, they lose money. So that's why your bank usually choose compound once a year. So when you look at your interest, they give you like compounding once a year type thing, because whatever the money you have and divided by 12, and then they give you that much interest as your interest, okay, as your the money that you make. All right, so this formula will show you that by N having a more number, because N is your power, okay, N is your exponent. So if N gets bigger and bigger, you get more money you make, as you can see it. All right, so limit involving E. So if you have, say, your interest is compounding infinitely many, which means it continuously compounding. So that really actually become an E. All right, it's interesting, see it, but it become an E, okay? A limit involving E. So if this N is compounding like infinite way, okay, so many times, then that end up equal to E. So you have this, the test, the reasonableness of this theorem, try evaluating this. Okay, let's evaluate that. So x equal to 10, you get this number. X equal to 100, you get that number. X equal to 1,000, you get this number. Look at this. It is getting close to which number? 2.71, which is what? The E. So they're showing you, they're proving this numerically. Say, hey, look at this. I'm doing a numerically showing you when I change my X to be 100, I get 2.70. But when I change my X to be 1 million, which is X is getting bigger, okay, infinitely bigger, we get 2.171828, which is same as, it's getting closer to what? The natural number E. Well, look at this one. So given theorem 5.15, take another look at the formula then. Okay, we just learned that if you replace, remember right here, let's look at this one again. You just learned this. When I put this one, this is the same as what? Equivalent to E. right? We learned that by looking at this numerically, looking at this, we figured out x plus 1 over x, or you can say over here, what is this right here? You can say 1 plus 1 over x to the x, and limit x goes to infinity. You just learned that is equal to e. All right, which means remember this is the one that you have this one as a compounding daily, monthly, or quarterly, biannually. Then you realize compounding more often give you more money. But now I said not just the 365 days a year, but how about I do continuously, which means every second. Okay, that means you get a that and that to be e. So I have a new one now. It's saying, okay, if that's true, then we learned that. Here we learned that I can rewrite this problem, okay, as this: p to the e to the r. Okay, because you learned this, all right? This is the same as e. I replace that and I get e to the r. So that is a continuous compounding. By the way, I don't know whoever give us compounding it continuously. But anyway, if it's continuously compounding, you get this, 1,083.29 cents. It's a little bit more, I think. How much was it? What was their money? Yeah, so about 365 days, and then continuously about the same amount, $1,083.28. And let's look at this one. All right, you got one more cents. When you do 1,000, was that the 4? Just like that. Was that, you get the, I cannot remember the formula. R over N. So when you have this to be you get a $1,083.28. So this one has one more cents. By doing continuously compounding continuously, you get a little more money. But this 1 cent looks like it's nothing. But say if you deposit a lot of money, that 1 cent make a big differences. So when you compound continuously, that's the best thing for you, for money-wise, for saving-wise. But I don't know which bank does continuously compounding. I think they do annually, I believe. A lot of bank does annually. So now you just learn this. So if it's compound a discrete number n times a year, then you use this formula. If it's compound continuously, you use E. So you're gonna do, see it, you gotta see it, A is equal to what? Your principal amount and E to the times your interest rate and times how many years you do. So here's another problem. It's giving you a deposit of $2,500 is made in an account that pays an annual interest rate of 5%. Find the balance in the account at the end of 5 years if interest is compound quarterly, monthly, and continuously. Quarterly means n equal to what? 4. Monthly means n equal to 12. In this case, I'm going to use different formula, which is what? All right. So what is my R? That is my R. So my R is equal to 5%, which is same as 0.05. How many years you're gonna do? 5 years. So N is equal to how many? I mean, the T is equal to 5. My P is equal to 2,500. So we just plug into our formula right here. So you get this number for 4 years, 4 times per year. You compound times a year. All right, so you get 320509. You know what? It's not a small money that you made. Just look at that. With the $2,500, invested for 5 years with a 5%, you make $700, $705.09, which is a lot of money. So that is why you need to do the investments. Like if you work, you need to join 401k. Because the 401k, it's compounding, you know, every time you put in your money. Okay, your interest that you have, the interest also get into your investment. So your money grows faster. Okay. So next one, look at this one. If you do for compounding 12 times a year, you get 3208. Let's just see the differences. 3205 and then what? 3208. It's about $3 differences. It's not much, I guess, but it's okay because every penny counts. So you want to compound more often. So if you do continuously, you get 3210, which is about what, $5 more. All right, any questions from today's lesson? Is everybody good? All right, so that's it for now. Then you have exam, not next Tuesday, but week from Tuesday. So you have a chapter 5 exam on Tuesday, and you have your final exam on Wednesday. So I want to make sure that you all, okay, let me just make sure that you guys all understand what's going on because we don't have many days left. So when you look at your PowerPoint, so look at this. All right, so you have to do this. Okay, final exam review problem. The reason is I'm gonna choose that to give you your final exams. The final exam comes from this part. So you need to do this problem. Because I will choose from here about 20 problems and give you that. Okay, it has like, I think it has like 80, I cannot remember how many problems that should have. It has 40 problem, okay? It has 40 problems. I'm gonna choose 20 out of this. So maybe I would choose less, but I know I would choose problem from this review problem for your final exam. So you have to do this. This is not an optional one, but this is required. You have to do final exam review problems. So you need to start working on not just the chapter 5, not just the chapter 5 homework problems, but you need to do your final review problems too. So this weekend, spend your time doing your final review problems because I will go over those. Any of the things you have a questions, you can ask me because you have exam, not next week, but the week after, your chapter 5 exam Tuesday, your final exam Wednesday, and we're done. Remember, November 25th is the last day. So everything you have done, you need to finish like any homework, anything, any projects, anything that needs to be done by November 25th. That is your last day of this semester. And I'm gonna turn it in your grade probably the 25th after you finish with the exam.